Hello students, you are welcome to this session. That is session 4 of Unit 2 of Pedagogical Content Knowledge in Chemistry. This session is specifically going to look at preparation of solutions. Let's proceed to look at our objectives for the session. Now, by the end of this session, you should be able to define a stock solution, define a standard solution, define a dilute solution, explain the meaning of assay, and calculate the concentration of stock solutions. So with the various definitions that we have to do, we are putting them as or under definition of terms. What is a stock solution? It is a concentrated solution from a chemical shop or laboratory from which a dilute solution is prepared. So for this solution, it is usually of a very high concentration that sometimes it is dangerous to work with. And in most cases, that is the solution that we pick some of it, then we will dilute it to get a lower concentration. So we prepare dilute solution from stock solution, and they are those ones that we usually obtain from chemical shop or laboratory. Standard solution. It is a solution whose concentration is accurately known. We have mentioned dilute solution. What is it? It's a solution prepared from a standard solution by the addition of water to a measured quantity of the standard solution. So we pick part of the standard solution in which we know its concentration, and we expect its concentration to be higher as compared to a dilute solution. So we pick some, and then we dilute by adding water to it so that we get a solution of lower concentration, and that is the dilute solution. The next one is assay. An assay refers to all the necessary information provided on a label of a container of a chemical. So when you pick the container of a chemical, you see that they have provided some information there, and that information is very important in knowing the concentration of the content of the bottle you are holding and some other properties. So when you pick the container, or container of a chemical, these are some of the things that you see. You see the density, the molecular mass, and its experimentally determined purity, as well as the impurities. Now, assuming you want to prepare a solution, what apparatus are you going to need? Depending on the type of solution you are going to prepare, you need certain apparatus. But these are some common apparatus that are almost always present in preparation of solution. Volumetric flasks of various sizes depending on the volume you want to prepare, beakers, glass rods, that's when you have to stir, measuring cylinders when you have to measure, weighing balance when you have to weigh something, pipettes, burettes, funnels, etc. You need some of these things when you are preparing a solution. So our last objective is to perform calculations involving the concentration of stock solution. And so we have this problem here to try our hands on. We have been provided an assay, and in the assay we have mass density, we have the purity, and then we have the molar mass. What do we do? The task is to determine the amount concentration and the mass concentration. So in doing so, there are multiple ways of doing or finding the concentration. This is one of the ways to do. By using the relation amount concentration is equal to 10 times the density times the percentage purity divided by the relative molecular mass. So in the question, we have the density, we have the purity, we have the molar mass. We just do a substitution and we obtain our answer. Now the next thing to do is to find the mass concentration. And if we know the amount concentration, finding mass concentration is very easy, especially in a case where we've been given the molar mass or the relative molecular mass. We know that mass concentration is equal to amount concentration times the molecular mass or the molar mass. So what we have calculated, which is 16.67, being the amount concentration with the unit mole per dm cubed times the molar mass, in this case 63, so this is 63 grams per mole. When we do this calculation, we are going to get 1050.2 grams per cubic decimeters, and that is the mass concentration of the chemical in that container with such assay given. We are ending the session with these questions. Please try solving them.